Kalispera from Athens, where we've had a glorious springtime day today. Kalimera in the US. Welcome and thank you for joining us for yet another lecture in our virtual lecture series. After two recent lectures in March by two important historians on modern Greece, on the occasion of the bicentennial of the Greek Revolution, today we move away from history and from Greece and delve into a topic that for me, at least, is complicated. It's complicated to understand, but I guess necessary to know something about. We will be talking about artificial intelligence and blockchain. The topic is data power to the people. We are privileged to have as our guest speaker for today's session, Vassilis Papakonstantinou, technology entrepreneur and co-founder and vice chairman of the MIT Enterprise Forum Greece. Vassilis holds degrees in mechanical engineering from the National Technical University of Athens, the Polytechnio, and in ocean systems management from MIT. He has conducted research in automated control systems, risk management, and system dynamics. He is an active volunteer of the MIT Alumni Association, and in Greece has served as chairman of the MIT Alumni Club. Vassilis also is co-founder and treasurer of the Greek Technology Enterprise Forum. That's also known as the Hellenic Innovation Network. This US-based charity supports the entrepreneurial growth of the Greek tech ecosystem. Vassilis is a technology entrepreneur with over 25 years of hands-on experience across a wide range of industry sectors. We are grateful that he can join us today. Facilitating the discussion is Marina Hatsopoulos, who, apart from her other attributes, is intimately connected with CYA because her grandmother started this institution. This, I'm proud to say, makes her my niece. Marina is an entrepreneur, a very successful entrepreneur and a writer, and a member of the advisory board of the MIT Enterprise Forum Greece. She holds BA degrees from Brown University in math and in music, and a Master of Science from the MIT in mechanical engineering. Marina was founding CEO of the Z Corporation, an early market leader in 3D printing out of MIT from 1994 through its sale in 2005 when it reached $30 million in revenues. That was a very successful company and a pioneer of its kind. And now Marina is a board chair of Levitronics Technologies, the worldwide leader in magnetically levitated bearingless motor technology. Marina is a member of the National Board of Research and Innovation of Cyprus and is also the president of the Hellenic Innovation Network. She has published articles, essays, and short stories, a talent which she's discovering later in her life. And all these things appear at windystreet.com, windystreet.com. There you will find her latest article, really worth reading, entitled The Danger of Success, the CEO Syndrome, which really describes how things can go to your head if you're successful, how success makes you turn, makes your head turn, and how to avoid that. Before I pass the floor to Marina to lead the discussion, I'm sure you will have realized that by now we are using the normal Zoom meeting format instead of a webinar. This means that those of you who are CYA alumni can see who else is watching, maybe recognizing old classmates. As always, may I remind you that this session is being recorded And this discussion will be saved and archived for CYA's future use. So if someone doesn't want to share the video or be recorded, please switch off your cameras. Marina, take it away. The floor is yours.
Thank you so much, Alexei. As you mentioned, I'll be helping facilitate the procedures of today's lecture. I have had the good fortune of knowing Vassilis Papakonstantinou since he got me involved with MIT Enterprise Forum Greece, which he co-founded back in 2014 with the purpose of enabling technology entrepreneurs in Greece to rapidly transform their ideas into world-changing companies. He and I also work together on the Hellenic Innovation Network, an organization that we've built to leverage the Greek diaspora to help support the entrepreneurial growth of the Greek tech ecosystem. As you mentioned, CYA was founded by my grandmother, and I was delighted when my daughter attended CYA a few years ago and really had a life-changing experience. So it's my pleasure to be here today. Throughout the discussion, feel free to write any questions in the chat box, and we'll get to as many of them as we can at the end of the presentation. By way of a brief introduction, a few years ago, all anyone could talk about was Bitcoin, which has jumped from a price per coin of 6 cents back in 2010 to $55,000 per coin today. So it's kind of crazy. And that hysteria extends into blockchain. And every startup pitch I see has that on it. And now that has converted into a hysteria over artificial intelligence and machine learning. So some of the questions we'll have today will surround all these new technologies and the interplay between them and how this will impact our daily lives. So I'd now like to pass the mic to Vassilis Papakonstantinou for his presentation titled Data Power to the People. Vassilis, the floor is yours.
Hello, everybody. Dear Mr. Papakonstantinou, thank you for the invitation and your kind words. Dear Marina, thank you for making time to discuss this very dear topic to my heart. We have done so many things together, so it's an interesting rearrangement of roles today. I started working with AI back in 2012, and although I've been in this space both as a technologist and entrepreneur, I still consider myself a student that loves to learn new things, and I'm amazed about from the new developments and the opportunities AI creates. But I'm also mindful of the challenges, but still I'm optimistic about the future. Today, I'm going to share with you some key facts about artificial intelligence and blockchain, hoping to help you better understand the challenges, opportunities that they are ahead of us. And I would love to have your feedback and possibly inspire some action. So if you remember, I'm sure you've seen that any baby, fairly early on can joyfully point to any kitten she sees. It just takes only a few times to hear her mother pointing to a cat nearby and saying "nice kitten," and then over the course of a few days, she will realize the connection between the label kitten and the type of furry animals, irrespective of the color and size that the cats are around. But if you try to do the same thing with a machine, that will happen quickly, but it will require a huge and diverse data set with millions maybe of different cats from different angles, different lighting conditions. The machine will somehow analyze these images and will try to pick up the features, the characteristics that define the animal cat, and using that, it will be able eventually to tell a cat. If you take a step back, on one hand, you see that this tiny baby brain requires only a few data points to learn over the course of a few days, and it requires only drinking some milk. On the other hand, you have a computer that requires millions of data points. It can learn fairly fast, but it is consuming a lot of energy. So you may ask, what's the point? why do we need to invest in this technology? The point is, once we get the machine to be trained to understand the underlying concept, it will be able to do this repetitive task almost forever, much faster and much more accurate than any human, producing fairly consistent results. Of course, the point is not to identify cards. I mean, that's the example, but you can think instead of identifying meteors crossing the Earth's neighborhood or catastrophic storms forming over the ocean or potentially deadly viruses spreading or cancerous tumors in your body or DNA sequences that they connect to these medical conditions. So the point is to let the machine do, the thing that it can do fast, accurate, and fairly consistent, and let the human focus on managing the results, paying more attention with what matters, and together forming some kind of an alliance. So if we take a step back, we can define artificial intelligence as a subject of computer science that enables computers and other machines in general to mimic the perception, the learning, the problem solving, the decision-making capabilities of the human mind. Most people, you may connect AI with robots because that's how the Hollywood used to present them, but you have AI also in the form of pure digital software format, like the digital assistants you may have on your computer or on your smartphone. The effort to create AI goes back in time. I mean, in theory, you can consider as some kind of an intelligent machine the automatic doors of Hieron of Alexandria, or the Antikythera mechanism, or even the automatic servant of Philon. But the modern efforts to create AI date back to the 50s. The idea then was to hard code the knowledge, but the results were limited. And after going through a series of what they call winters, eventually in the 80s, the scientists and technology engineers developed machine learning, which is a different way of implementing AI applications, enabling the computer to figure out the intelligent part using just data and without any explicit programming from the human itself. Machine learning, or ML for short, is the hottest field of AI these days, and it's important. It's going to grow in all aspects of our lives. Machine learning uses different types of algorithms to solve different types of problems, and a very particular promising subset is what we call deep learning, that enables solving these more complex problems using neural networks. Neural networks, you can think of them as mathematical constructs that try to mimic the way the connected neurons work inside any living brain. The idea behind AI is, of course, to mimic human intelligence, but the truth is we don't really understand human intelligence. There's a lot of research going on, but still we are far away from that. At a higher level, you can think of human intelligence as a set of mental models that help humans transform input in some kind of output. For instance, my words are one kind of input into your brain, and your mental models can create a question you would ask me later, or help you drive a decision that you will implement after this meeting is over. Some of our mental models are the result of nature, while others are the result of nurture. Maybe, my urge to eat any chocolate I see around is certainly part of nature, but our ability to do math should be attributed more to nurture. The truth is that these things, nurture and nature, interplay with one another, and the mental models are more primarily the result of a combination. In a similar way, you can think of AI as a set of math models that help machines transform input to output. For instance, a photo of a cat will be processed by the mathematical models inside the machine, and it will be transformed to a label, this is a cat, or to some kind of an action, for instance, feed the cat. you can think of these mathematical models as a result of digital nature, in this case, humans that have created the generic algorithms, and of course, nurture, which is the process of training these generic algorithms to learn a very specific task. So let's take a look at how that works with a simple example. The training, the nurturing of AI starts with data. Let's say that we want to create a system that I can identify a cat from other animals for whatever reason. So we need training data. You can think of that as lots and lots of pictures of cats labeled data, photos of cats labeled cat, and lots of photos of other animals labeled not a cat. In this particular case, a photo is the X value corresponding, and then the corresponding label is the Y value in this observation set, in this set we see from our real world. Then you have to select a generic algorithm that is suitable for this particular set of problems, and the goal is to train this algorithm to tell any future photo X and decide if it's a cat or not. So to do that, we essentially have to pass every photo we have in our training data set into the algorithm and let it produce some kind of a result, which will be typically a decision, it's a cat or it's not a cat. Then what we do is compare the output of the machine with what we know from our observation data, and then calculate this difference and tell to the machine, yeah, listen, this try you didn't do well. Initially, the machine will be guessing almost randomly, but over time, through this iterative process and the feedback loop we created, it will be able to change these parameters, the generic parameters it started with, and eventually become increasingly better and better at identifying cats as cats and non-cats as non-cats. And at that time, we say it has converged. The difference from that point onwards will be small and will not be increasing. So we can say that this model is trained. You can if the description is not very clear to you, you can think of a similar problem. Like you visit a hotel and you want to take a shower and you want to adjust the temperature of the water. Because it's the first time you visit this hotel, you don't know how the faucet works. So initially you set the handle of the faucet at a random position. And then you use your hand to test the water, and eventually just moving around back and forth the handle, you can get to the right position after a couple of tests. Although, solving the problem with the water is fairly trivial and you can do that very quickly, the case of training even just an algorithm to understand cats is not as simple, and it may take several, maybe sometimes millions of iterations. Eventually, the algorithm will be able to identify cats with high probability, but occasionally make some mistakes. Some of these mistakes will lead to misidentifying another animal as a cat, or say a cat is not really a cat. So at this point, these mistakes identify what we consider the accuracy of the system, and the system then is ready to take it into whatever real life application is you have in mind, and feed it with real data and expect it to have fairly good real results. The process I described may take a few hours, but the results are very good, but they are very good only at identifying cats. If you need to identify cats and dogs versus other animals, then you have to retrain the algorithm with a new data set. The point here is that artificial intelligence, the way it is right now, it's very narrowly focused, and you cannot extrapolate. It cannot extrapolate from experience, even in these adjacent fields. Like you cannot train it for cats and then just add the training for dogs. Machine learning algorithms can be can be used to solve three broad classes of learning problems. In the supervised, what we call supervised learning can be used when we have, as I explained before, sets of data X and label Y. If we take this example here, you have a photo of an apple and it has the label, the word apple. So the goal here is to teach the machine to map any future instances of apple into the correct value of apple and tell the apples it sees. Using supervised learning, you can solve several problems. For instance, forecasting price commodities, or scan and identify people as they enter into a secure facility, or identify tumors in an MRI scan. Unfortunately, most data doesn't come with labels. Certainly, apples don't come with labels. So sometimes most of the times actually, you need to have humans label the data, and that's a very expensive and tedious work. If the benefit is not such, you may end up using only unlabeled data. And in this case, you need what we call an unsupervised learning process. In this process, the goal is not to have the machine identify a very specific thing, but identify the specific and learn the underlying structure. In this example, if we show the machine pictures of apples and oranges, it will group the apples with the apples and the oranges with the oranges without actually knowing that each of the group members are apples or oranges. We use supervised learning in different settings, from identifying problems in engines and in order to initiate preventive maintenance or stop potentially fraudulent financial transactions from happening. But there's a third class of problems where we have to teach a machine to take actions in a dynamically changing environment. Then in these cases, we need to use what we call reinforcement learning. The easiest way to explain this is the following. Imagine that you have not played Pac-Man before, and when the game starts, you just start moving the joystick, and you see your score randomly increasing when you eat small dots. It jumps a little bit when you eat larger dots, and then you encounter ghosts and you lose. You quickly put things together and you understand that you have to take actions to maximize your rewards and avoid other stuff. And eventually you realize that, if you think of the large dots as apples, to continue the previous set of examples, you figure out that an apple a day keeps the doctor away, because you realize that these apples enable you to eat the ghost. Of course, we are not using reinforcement learning just to learn machines to play games, although there are very important examples like the famous AlphaGo. But there are other very important applications, like helping them to learn how to drive autonomous vehicles in different settings without actually having to drive the car all the time, in order to teach the algorithm how to do that. Machine learning is all about creating math models, as we discussed before, in order to help machines turn input into output. If you remember from your high school or college math, you know that if you have a set, and sometimes fairly small set of pairs of X and Y values, you can do a thing called regression to estimate a function that connects values of Y with values of X. And eventually it allows you to forecast any future value of Y based on new values of X. But the problem is we have these good math models only in school. These very accurate math models are a luxury in real life, and usually in real life we have sometimes we can have approximations, but not it's not always possible. So take for this example, how could you teach an autonomous car that the thing in the yellow box is a car, and that the things in the purple and green boxes are not real people, as you may have expected, but rather images printed on the back of the car? In real life, examples like these are very often, and the math models we have are limited, if any. So in order to compensate, we have to use big data. Big data, you can think of it as large collections of data collected from sensors, for instance. So think of it as videos and photos from cameras fitted on a car driven by humans, or the actions the human driver takes while driving the car around in different situations, the corresponding GPS locations where the decisions are taking place, the weather conditions and other conditions. All these data in different settings, you would fit them into the algorithm in order for the algorithm to try to understand a structure that defines the problem, and in this particular example, be able to identify that the thing in the yellow box in front of it is just another car, and it should act appropriately and avoid crashing into that. The thing, though, is that heavy reliance on big data may lead to problems, data bias problems. For instance, take the fatal accident of a Tesla a few years ago that led to the killing of the driver. The car was on autopilot and hit a concrete barrier because in the past it had not received any training data with the barrier in place. So in a sense, the barrier, when it tried to cross the lanes as it had done in the past, was invisible to it. What happened was a very tragic accident, but most probably it will not happen again, because this particular sad event became a training data point for the million of other cars that are on autopilot. This heavy dependence on data is like an addiction. And as you would like to expand the applications of machine learning into more and more broader spaces, you need more and more data, which means you need more data in order to increase the known knowns and decrease the unknown unknowns that sometimes, as in this particular case, can be fatal. Thank God, the data production, the big data production of our world is exploding. Just look at the picture and what was estimated to be the data production over the course of 60 minutes. And that's an estimation for 2020 before the pandemic. If we could measure actually the numbers, the real numbers would be much higher because of the massive amount of activity, of human activity that was moved online because of the pandemic. So it is estimated that more than 95% of global data was created over the past 2 years. And take into consideration that 50 plus billion of connected devices, anything from smartphones to wearables to smart homes to connected cars and you name it, are online or become online over the next few years. In 10 years from now, most probably this number will be 99.99%, and most probably it will not be over 2 years. Maybe it will be in a year or less than that. So I'm sure you have heard that the digital data is the new oil. Oil helps people move from one place to the other, no matter what they are driving, even a classic Desevo or a modern Porsche. The difference would be the time it takes you to drive from one place to the other and the comfort you have in each vehicle. But this is where the inequality, if you can call it, ends. In the digital oil, the access to data has more and far-reaching effects and can be very different. Sometimes the difference between life and death, as we saw in the unfortunate case of the Tesla owner who was missing just a data point, like the fact that it had to be trained with the concrete in place. One particular issue that makes digital oil from real oil different is the fact that the digital data can be double spent. That means that although you cannot share the exact same set of atoms of matter at the same time with somebody else, you can share the same bits of data with anybody else, actually with everybody around the world. That means that once the data leaves your device, it can go anywhere and fuel anybody's machine learning algorithms, creating no value for you as a producer at best, or having potentially detrimental effects for you at worst. So you can think of it as a dilemma, sharing or not sharing. Should I keep my data to myself and maintain control over ownership and value, or should I share it with everybody else in order for a mutual benefit. Let's take the example from health. Should I keep for myself the fact that I have a very rare medical condition and that has specific effects, or should I share it with the research community, enhance the global understanding about this particular condition, and eventually get to a global cure that will benefit not just me, but everybody else? This is typically a very simple question. Can I have the cake and eat it too? Is it possible to selectively share our private data for the common good, but maintain our privacy and the value that results from ownership? Well, the short answer is yes. There are a couple of ways, but I will talk primarily about the one based on blockchain. Before I go on with the how, let me spend a few minutes explaining some basic facts about blockchain, because I have the feeling that most people confuse blockchain with the main application, which is Bitcoin and other cryptocurrencies that Marina mentioned in the beginning. Well, formally, you can define blockchain as a public, immutable, and distributed ledger that enables trustless transactions. I know it's a mouthful, so let's break it up a little bit. So you can think it as a large database that can record any kind of transaction, and it's kept in multiple copies around the world. Each copy gets synchronized with other copies through a process called a consensus agreement. It's a very specific process that ensures that all copies hold the exact same data, which you can refer or can hear people talking about the true state of the ledger. The database is open to the public, which is rather unusual because most databases are controlled by their owners. So anybody can inspect the records. And there is a mechanism that ensures that once a record has entered into the database, it's almost impossible for anybody else to go and change it for their own benefit. So in this, using this database, people can transact with others on the basis of the data they see without having to trust the other party, hence the trustless concept in the title. So the first step to ensure trust on the ledger is to think of as the following example. Think of a physical ledger, a paper ledger that you want to record a new transaction. Okay, so you have two people that they want to work with one another on a specific thing. You find the first line, you write down the transaction they completed, and you have both people sign at the end of the line. A very typical one. You know, I'm sure most of you have seen that. But what happens if individual A wants to play a trick on individual B? C or he can go later on, find the bookkeeper, bribe him, and do the change that suits her or his own needs. Most probably, no one will tell the difference between these people, and maybe accidentally only it will be possible for anybody else to identify the difference. In this case, there will be a dispute, but the problem will be primarily that everybody else will lose trust on the bookkeeper and the ledger. So we have to find a different way. How, if we could, instead of having just the two people sign at the end of each transaction, if we could get everybody else to sign, think like if you go to people, individuals C and D, you will not ask them just to themselves to sign, but you also have the individuals A and B, and every other individual that before that had to record a transaction. Then it will be highly improbable that somebody will not notice at least the records that involved him that had been maliciously changed by somebody else, and that will ensure that this idea will ensure the immutability of the blockchain. Of course, having everybody to sign physically, that's just possible only in the thought experiment I described. And in reality, what we're doing, we're using cryptography to achieve this goal. The second thing we do to ensure trust is that this ledger is not kept in a single copy, but it is kept in multiple copies around independent computers around the world. These copies get updated each time a new record is entering any other copy. This process again ensures that no malicious actor has the incentives to go and alter the state of the ledger for his or her own benefit. It's difficult to grasp, so you can think of it in this way. You know, if you wanted to increase your chances of winning a lottery, the best thing you could do is to start buying more and more tickets. But as you buy more tickets, you spend more money, and eventually you come to a point that it may not worth the benefit of winning the lottery, because you know it will be so expensive, and the probability of having to share the winnings with somebody else that bought just one ticket increasing. So you don't have this reason to go on. And this is the similar concept with the case of blockchain. So these two things ensure immutability and security of the blockchain using primarily, of course, as I mentioned before, cryptographic technologies. Of course, transactions are the result of formal agreements, formal contracts. So, you know, think of the following case. You want to buy a song from me, we agree on the price and the delivery date, and when you get the song, you pay the price, and everybody is okay. But sometimes people don't try to just change the transaction records. The example I mentioned before, they may try to change the agreement. For instance, you know, somebody, a producer of a song realizes that the song is becoming a hit, and then at the very last minute says, "Oh, I want more money," without the agreement of the buyer. How can you address this problem? Well, an idea could be to not just record on this very interesting database I described before by the name of blockchain, just the data, but also store the contract. You know, codify the agreement in the form of a computer program. So when the two inputs, the money and the song, are presented there, then the whole thing will execute itself automatically. And in this way, because the mutability of the ledger we described before, nobody will be able to not just change the transaction details, but also not change the agreement terms. This again is possible because of the blockchain, and what I described is in essence what you may hear as smart contracts, namely programmable versions of contracts residing on the blockchain that can get executed automatically when the conditions are met. It's a lot easier to visualize the smart contract with the case of digital song, but there are so many applications in the physical space that make it very, very interesting. If we expand, you know, in the example, the smart contract was about a song in the digital format, but what if we could generalize, and instead of the data that represents the music, we can have any kind of data, from health to income to driving to whatever data produced by any individual or any group of individuals at any given time. Then we could create smart contracts that codify the use of the data, the conditions of use, the value exchange, and in essence, we could, you know, have our cake and eat it too, as I mentioned before. This way, you could selectively share the data, be sure about who is using for what reason, avoid the value decay over time, and most interestingly, get returns throughout the life of the valuable life of your data. You may think of that as a tokenization of personal data. So again, generalizing, we can have a blockchain allowing each of us to pump out the digital oil and then use it to power our own machine learning algorithms and selectively share it with others in order to either power their own digital data or use our own models for their own purposes. You can think of the result as a decentralized intelligence structure. In this decentralized setting, you don't have just the trust, but also the incentives to share your private data and improve the global intelligence without relinquishing control and the privacy, because you can revoke the data or the rights to use the data whenever that is of interest to you. And you can do that at a global scale because you don't have to go around, looking for your data with every person that asks you or to use it, and do that across space and time and across applications. You can think of a couple of applications that are relevant and will help you, put the whole thing together and understand the big picture about these opportunities. Think of the case where you have digital health, your digital assistant like Siri or Cortana or whatever else you're using, and things like behavior-based insurance, which is cropping up, especially in the States. I'll spend a couple of minutes to share an example to help you put these things together and realize the value. Let's assume that you have a medical condition like diabetes, and you require some fine regulation of various parameters, like the medication you have compared with the physical activity you're planning and the environmental conditions, heat, cold, etc. So you wear a patch on your arm, they're becoming more and more available, and that patch regularly measures glucose and other things and pass them to the data to your smartphone. Then once the pandemic is over, you say, oh, okay, let's go a long trip on my own to another country in order to relax. And then you start go sightseeing and you get carried away and you don't pay attention to the dehydration that results from spending a lot of time working around under the sun. And then problems start to happen. Your digital assistant could estimate the probability of you fainting out, and warn you to take action, but because of your concerns about privacy, you don't give permission to share your data with the medical condition model of your insurance company. So eventually you faint, and it's just a miracle that somebody passes by and takes you to the hospital at very last minute. People from the emergency room trying to figure out what's wrong with you in a language that you don't understand, and you are halfly awakened and you cannot help. Eventually, the thing plays out, but you come too close to lose your life because of your legitimate privacy concerns. If we think of a different scenario, which is my more favorable, is your digital assistant is connected to a network of emergency responders via a distributed intelligent application like the one I described before, that uses smart contracts that enables you to share selectively your data for particular purpose with particular people. So once your digital assistant realizes that you're in an impending emergency, it alerts an emergency responder connected to the network and shares that location and medical conditions that you don't want to share with anybody, just in order to help the emergency responders show up in time, treat you with on the spot with the right medication, and get compensated without having you to do anything. You could be on your way in a few minutes and enjoy the rest of your vacation, and the whole incident will be just a memory. And at the same time, you could save the data and keep it under wraps, away from the prying eyes of individuals and organizations you don't want them to have. This happened to be the original use case on which we founded my company, Mobiltron, a few years back, because actually a dear friend had a fatal accident in a similar setting. There are countless of other applications that, although they can benefit from private data, many of the users they don't share that data because of privacy concerns, and we globally lose this improved knowledge. Without the blockchain, these things, the data privacy and a global knowledge on a very particular subject, are kind of orthogonal, and they would not be possible. The technology community is working on improving the underlying technologies. There are so many things in this space, but it's not just about the technology community. We need other stakeholders like the government to work on the social frameworks that will enable these technologies to seamlessly enter our daily lives. We're not there, but we are getting closer. So back in 2014, when we founded Mobitron to develop this system, we called it Wover, we were confronted with this problem. You know, how can you enable the group of people to benefit from the use of valuable data without letting its member to lose control of the data? Blockchain was in the early days, as Marina said, you know, people were, were not even paying attention, and certainly it was not possible to create distributed applications like the one I described. We came up with a process, but it was centralized. So the individuals had to trust us at Mobitron in order to maintain the privacy of the data while they were sharing this very valuable data themselves. Thankfully, neither us or any other application creator right now has to take over the burden. This combination of AI and blockchain can enable trustless and selective sharing of private data to power this distributed version of AI that creates benefit for both producers and consumers. So in this respect, these networks can be more valuable than the sum of their parts without sacrificing the privacy and the individual benefits each one of us enjoys by being part of the network. This is a very exciting space. A lot of things are happening, and I'm sure that more things will come in the past. I hope I gave you a bird's eye view. I'm sure you have more questions than answers. So thank you for paying attention, and I would be happy to have your questions and discuss that over the next few minutes.
Thank you so much, Vassili. Wow, that was an incredible overview of several different technologies, and you did an amazing job connecting them. Talking to us first about how repetitive tasks can be done faster, more accurately, and more consistently using artificial intelligence. And then how our legitimate privacy concerns can be addressed through the use of blockchain in order to enable us to get all the benefits of artificial intelligence. And I think your example relative to health data is a great one, because we don't want to share all this data publicly, but we do want to get the benefits of all the shared learning from other people who are going through the same experience. So the first question we had was one that I wanted to ask you anyway. So running Bitcoin requires more energy than New Zealand and Belgium put together. Why is that? And do you think there will be regulations as a result of that? Can you talk to us about the environmental implications of cryptocurrency in general?
Yeah, that's a very important question. In order to make sure, do you remember this example I gave with a lot of people signing the same line in order to make sure that nobody plays tricks? So we couldn't do that, and we're using cryptographic methods to do that, which means that we have to dedicate computers to solve very difficult problems, and eventually through this process maintain the state of the ledger. That is what you may have heard as a proof of work, which means people prove that they work through the consumption of energy in their computers and make sure that the state of the ledger is okay. And that creates problems because, and you have two kinds of problems, because you have to spend energy on the computer in order to do these very complex computations, but also you have to spend energy on cooling the computers with air conditioning in order from avoiding to melting down. There are alternatives to this protocol called, for instance, proof of stake or others, proof of transfer, that save this problem. It's for sure that the main blockchain, like the Bitcoin blockchain, which consumes most of the energy, will be there, and people are trying to use slack energy. Yesterday, I was listening to an example where, you know, when you have these oil wells, you have these head fire that you see at the top burning all the time. So people in the blockchain community go there and they ask these people, instead of just throwing this carbon into the air, let us consume it in order to produce energy. So the blockchain community, the technology community are coming up with interesting ideas to either reduce the energy consumption and avoid problems, or find alternatives to the energy consumption.
Thank you. We have another question from Brian Nichols, which is, how exactly does blockchain help preserve privacy? It seems that encrypted sharing directly with selected, trusted other people would also work. Is there a problem with that?
Yes, it could work, but then it means that you would have to pay attention to every transaction that you would promise. Like, you know, if you wanted to take this example with health, and there were 50 people that wanted to have your daily walking pattern, how could you share with everybody and make sure that each person was a trusted person that would use the data for his or her own very stated purpose? So the problem is not, it's not that you cannot engage with somebody that you know, but the problem is that you want to expand that in a way that it is humanly impossible to maintain control of the whole thing. For instance, if we do the same thing, like if you recorded the song and you wanted to share it with Marina and you trusted Marina, then it would be fine. But how can you make sure that anybody that Marina sends the digital format of the song will pay you back X amount that you agreed to have? So it's a matter of size. It's not a matter necessarily of you know, interacting with people. You know, it's interacting with people that you don't know at a huge scale, and think of it not just at the level of humans. You know, if you have a electric vehicle, okay, and you want to rush into a very important meeting, how you can negotiate with another electric vehicle to give you its energy and charge you, or allow you to charge before the other one, in order to get to the, so think of this dimension as well.
Thank you. That's great. So we have another question from Whitman Knapp. Will quantum computing and AI ultimately be able to crack the code for Bitcoin and make it worthless?
Yeah, that's a very regular question when you have these discussions. Yes, but also no, because in this thing, the implicit assumption is that only the quantum computing will be used for the people that try to break it. But you can have the whole blockchain move into a quantum computing based platform, which will increase the whole thing. And you know, the point is that quantum computing, although we hear so many things around, it's fairly far away, and there are other opportunities in that it will be more useful immediately. So I don't think that's going to be a problem.
I have another question for you, which is, what are data trusts? I've read about them. Can you talk about them?
Yeah, data trusts are, you know, human ideas to solve this problem. Okay, and I think they resemble the idea of having a real trust. Like, you know, you have your estate, and you want to make sure that it will be distributed according to your will, and that is a legitimate thing in the Web 2 space. But if you enter the Web 3 space, which is based on blockchain, then essentially the need for data trust is replicated by smart contracts. You don't need to have a data trust people to handle that, because you can encode everything into a digital contract and let it run on its own. So, you know, I think the equivalent would be how papers moved from paper to the original digital format, and they were a similar thing in just a different concept, but without realizing the full potential. So these data trusts are a solution to a problem, but with maybe an outdated technology solution. as opposed to having smart contracts.
Great. Thank you. We got a question from Etta Harkness Bartoldi. I am writing my master's thesis now on AI technology uses on border security. What is your opinion about the ethical use of AI technology like RoBorder, Eurodac, ETIAS, EU LISA, and more?
Well, in general, over the past year or so, with the spread of the discussion of AI and with all these successful examples, the intercourse has gone outside the technology community, and these things about ethical use of computing, understandable computing, explainable computing, explainable AI, ethical AI, etc., are very important. AI is a tool, much like any other tool, like the knife. You can use it to save a life if you're a surgeon. You can take a life if you're something else. So I think we need to have this discussion, and I think in order to have this discussion in a legitimate way, both what we call techies and humies have to understand the underlying concepts, because sometimes the discussions get carried away because we either underestimate or overestimate the potential of technology. So it is important for me as a technologist to have this discussion, but I think people should understand the real thing. Sometimes you will get misuses. It's part of the digital era where sometimes your data lead a winner takes all. But overall, we can come together, discuss, and find ethical uses in order to make it more efficient and more equitable.
Okay. We have a question from Dimitrios Dovas. Blockchain and artificial intelligence, such as autonomous unmanned ships, et cetera, will have social consequences like early retirement, increasing unemployment, increasing social security distributions, and pension issues. How beneficial will it be for humanity versus ethical concerns?
Well, there is discussion about a similar situation back in the early 1900s, when the car were going to take over the world, and people were concerned about the people that they were running carriages. Technology always takes away some things and creates new things. I'm not sure how would any of us feel be doing a repetitive task like manning a ship in the middle of the ocean under adverse weather conditions. And so yes, there would be things that we will go away, but there are so many other opportunities that they will be created. And this is something that we have to make sure that the younger generation keeps understands better, that the paradigm will be always learning new stuff. So that's the only way to make sure it can. Sometimes the discussion about AI and humanity is whether it will be against us, like Terminator. I mean, Terminator, it's the example everybody is using about AI. Skynet will take over the world. Yes, that's a probable scenario, but since we are cognizant of that, then we can try to work in a way that we find a way to make sure that AI gets some kind of our values. Even humans, they don't have all the same values, but the majority has the same values. We agree to live together peacefully and go on. So I think that it would not be against, it would be most probably for, and we have to find the ways to ensure that.
I think that is such a fabulous way to end the program. Actually, we've run out of time, and I think that was just a great summary in terms of the broader picture. I mean, at the end of the day, we are in control. So thank you all for your great questions, and thank you, Vassili, for this incredible session. You've educated us all on this new technology that everybody is talking about. So now we will all be armed with a little bit of knowledge that we can join in the conversation. So now I'd like to pass it back to Alexei to close it out.
Thank you, Marina. Thank you, Vassili. This was a fascinating discussion on a very difficult subject, of course, and the fact that so many people had questions to ask is a tribute to both of you for making it approachable to people like me, for example. Anyway, thank you again. I want to say to our viewers that we will be back again on April 21st at the same time, 12 noon in the US and 7 p.m. in Greece, with a special guest. This time it will be Greece's Deputy Minister of Culture, Nicholas Yatromanolakis. The minister will discuss culture as a driver for growth, as an underrepresented topic with a huge impact, both locally and nationally, especially in this post-COVID era. Facilitating the discussion will be CYA trustee and executive director of the European Studies Center at Harvard University, Elaine Papoulias. So we hope to see you all on the 21st. Thank you. Bye-bye.